Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this demonstration is what happens if I have a perpendicular bisector of a chord in a circle. So if you're going to follow along with trying to recreate the demonstration, what I'm going to be using is a pencil, a compass, and a straight edge of some kind, so that way we can see what happens when I have a perpendicular bisector of a chord. So to start off with, I'm going to begin by making a circle on a piece of paper. I'm not going to make it really big, but big enough so that way we can do more constructions on it. Okay, and just any random spot on the circle, I'm going to make a chord. And so I'm going to call my circle, let's call this circle T, and we'll call this X and Y just to give ourselves some kind of points to it. Using my compass, I will do the construction for a perpendicular bisector. So I'm going to open up my compass to be more than where I believe the halfway point is going to be, and I'm going to make an arc above the line from both endpoints of the line segment. So I'll come here and make another one. And what I'll do is same thing. I'm not going to adjust the compass at all, but now I'm going to make an arc on the opposite side of the line, and we should have something that looks like that. And I'm going to come back here and make this one a little bit longer. There we go. So there is the construction that we would do for a perpendicular bisector. Now, lining up the points of my construction here, I'm going to draw in the perpendicular bisector. And just to kind of confirm, I can take my protractor and measure and say, yeah, these are, let's see, take the glare off of the protractor there. Yeah, these are 90 degrees for sure. And did I bisect it? I'll just check that with my compass here and say from here to here, that's whatever that length is, and from here to here, we see it's the same length. So we did create a perpendicular bisector, so I'll go ahead and include my right angle symbol here and add a hash mark here to show that we did bisect it. Now let's give this point of the intersection here, let's give that something. Let's call that point, I don't know, C, just to give it something. Okay. Now what we see is YC and XC are congruent to each other because we bisected it, and this is perpendicular to it. So I'm going to give these points here, let's call this L, and erase my construction mark here. We can call this M. Now, if we did the construction correctly, ideally, especially if you're following along, trying to do this on your own, what we should see is that the new segment that we constructed, the perpendicular bisector of the chord, happens to go through the center of my circle. And a chord that goes through the center of a circle is a diameter. So what that will allow me to conclude is if a chord is a perpendicular bisector, if it's a perpendicular bisector of another chord, then it must be a diameter. So here we started off with just a chord, and we constructed the perpendicular bisector. So if we were looking at this as a proof, I would probably be given the information that XC and YC are congruent to each other, and we want to be able to show that this would be a diameter. But whatever the measurement here is, this arc XY, well, because I am bisecting this, so if I drew in the central angle from point T, so I would create central angle XTY. Well, whatever that angle is, because I'm bisecting the chord, these arcs, the arc XY would also be bisected, so that would allow me to conclude that arc XM, so arc XM would also be congruent to arc MY. So if conversely, what I would be able to say is that if this arc MY and this arc here XM, if those are congruent to each other, then these two chord segments must be congruent to each other, XC and XY. And if these are congruent to each other and this is perpendicular, then obviously that is a diameter. So just like with a lot of the kind of theorems that we're working with in geometry, once I go it one way, I can take its converse and go back the other way. So that's what we're looking at here with perpendicular bisectors of a chord. If a chord is a perpendicular bisector of another chord inside of a circle, then it will be the diameter of the circle. But that's it for here. That's the point we were trying to make in this lesson. Thanks for watching, everybody.